This video is about scientific notation. It's a review because you've probably had it before, but like me, you might need reminders every now and then. And here's a very famous number shown in its scientific notation form. Why do we have another numbering system? Scientists deal with very large numbers. When you're talking about how far away the stars are, that's a very large number. Scientists deal with very small numbers. When you're talking about the size of a virus, that's a very small number. And because scientists, oh yeah, a little lazy. Okay. Simple format. So the scientists came up with a simple format called scientific notation. Big number, simple format. And the simple format starts with one digit. First digit of a number that is not zero. If you have 0, 0, 0, 2, 3, 1, you skip all those zeros. And then the decimal. And it's followed by all the rest of the digits. If you have any trailing zeros, you always erase those also. So if you had 1000, you put 1.0, but you wouldn't put any of the other zeros. You'd erase them all. And then you add the times symbol. Add the base 10, and finally add the correct exponent. Exponent, do you remember what exponent is? Oh, I gotta look that one up too. Oh, no, you don't have to look it up because I've got it here for you. Correct exponent. So this is what an exponent is. The exponent tells you, it's shorthand for meaning how many times. Instead of writing out 8 times 8 all the time, oh my gosh, so much work, you write down 3 to the second power. So it's shorthand for 3 times 3. 8 to the fifth is shorthand for 8 times 8 times 8 times 8 times 8. 10 to the 3 means 10 times 10 by 10. 10 to the 6th means 10 with 6 zeros. You don't have to go 10 times 10 times 10 times 10 times 10 times 10. You just put 10 with 6 zeros. Don't you just love base 10? I do. The next step is to move the decimal place. How do you move the decimal place? Well, I'm here to show you that. So let's do 879. So you write as 8.7. By the way, I'm using a mouse for this. It's not as easy as it looks. Got it. Then I count how many times I move the decimal. Okay, I moved it once, twice, so I put times 10 to the second because that's how many times I moved it. Let me make sure that you can see that that's the thing. Okay, that is how you do decimal. You can count how many times you move the decimal from 8.79 to get to the original number, and I moved it twice. And then you write the times 10, that's the base, with the count of 2. 8 times 7, 9 times 10 to the second. Well, here's write an example. You go ahead and do this too. So write it as the number 508, step 1. Step 2 times 10, and we got to figure out what the 10 is. It can be negative or positive depending what direction you had to go into. And this time we go 1, 2, 3, so it's 10 at the base 3. See, it's extremely simple. You just had to practice a bit to get this one. It has a 0 in it, so that 0 is significant. It's only if there's a 0 in the front with nothing else or a 0 at the end with nothing else that you even think about getting rid of it. So here's some hints on using base 10 exponents because they're so good. Recall that 4508 is really 4508 point. That's where the decimal is, and I put a 0 there just so you can see that there's a decimal there. Ask yourself, how many times did you move the decimal point from 4508 point to get to 4.508? If the original number is smaller than 0, then make the exponent negative. Otherwise, it is positive. Another way to think of it, if you went to the right, it's positive. If you went to the left, it's negative. How about numbers that are smaller than 0? Here we have 0.000458. Well, it's the same step. You write down 4.58. You write one digit that's non-zero, point, and then the rest of the digits, and you ignore any more zeros following after. Those are called trailing zeros. Times 10 to the fourth. How do we get that minus 4? So as you can see here, you wrote the number, So actually I'll do it over here to the side. 0, 0, 0, 4, 5, 8 is our number. I'm going to rewrite that. 4.58 times 10. Now let's go figure out what that is. So I went 1, 2, here's a 0, 3, here's a 0, and 4. There's a 0. So I had to go over 1, 2, 3, 4. And since this number starting out, see, that's much smaller than 0, right? So I come up here and say it's minus 4. See the little minus symbol? Sometimes it's hard to see it. Okay. How about these? I'm going to show you some and you tell me if it's scientific notation. Again, it's that specialized form, 1 digit, dot, and then how many other digits you have, times 10 and to the appropriate exponent. So is 11.34 times 10 to the second scientific notation? Pause if you need more time. Why, heck no, it's not. Why not? There should only be one single digit before the decimal point. 11 is 2 digits. So what does a correct form look like? 1.134 times 10 to the third is its scientific notation form. Okay, let's try another. How about this number? No. Why not? Well, heck, where's the decimal? So there's no decimal, so it's 847 dot. Well, that's certainly not scientific notation either. What do we have to do to make it scientific notation? Well, last one. How about 5.4803 times 10 to the minus 2? Yes, it definitely is. It is beautiful because has one digit, has the decimal point, the rest of the digits, no trailing zeros, times 10 to the base 10, and then it's got the exponent. Now, how about those trailing zeros again? So what if we have a number like 1,000? We write it 1.0 or listen to the video on significant digits. Maybe you do want to put 1.0000. But you put, let's assume that those are not significant, and then you're going to write 3.25 times 10, and then you have to figure out, well, how many places did you move it? And if you look here, you moved it 1, 2, 3, 4 places. So that's why it's 10 to the fourth. At this time, I'd like to say that the www.algebra-class.com scientific-notation is a good site to go to for further information. If you want some samples, they have online where you can quiz yourself. So if you're still uncertain about this, and I do recommend you practice, 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 practice. It will become automatic after a while, but it does take practice. It's not just one of these things you can think and say, oh yeah. Sometimes you want to convert back. I don't know why, but maybe you need to do it for exercise in your math class. So you have 8.2 times 10 to the minus 7th. What's that look like in real numbers? You want to prove to yourself you can do it. So an easy way is just write 8.2. Give yourself lots of space because that 7 is a big number. And you're going to be moving it 7 times. And it's a minus, so you got to make it smaller. Going this way, is that going to make it smaller? Isn't 82 bigger than 8.2? Yeah, so you're not going to be doing that. You're going to be moving it the other way. Like I said, you got to give yourself a lot of room. 8.2. You're going to move it 1, 2, 3, 4, 5, 6. Barely left myself enough room here, didn't I? And you fill in zeros for all these. Don't try and write small when you do this. Make it nice and big so you give yourself lots of room. And that's what the number is. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. So that's it. I hope you've enjoyed this little segment on scientific notation. If you have any questions, please see one of your teachers and we can help you out some more. Enjoy.